Here is a third example of finding the greatest common factor, or GCF, of an algebraic expression. So in this example, we're going to look at the algebraic expression 2xy squared plus 4x squared y to the fifth. Now, we have a y to the fifth here, so I can already tell you we're going to want to use that shortcut technique that we talked about in the previous lecture, because otherwise we're going to have to write out y times y times y times y times y, which is going to be a little tedious. We'd like to avoid that, but we'll discuss that when we get to it. So anyway, for now, find the GCF of the coefficients, just like we've done before. So 2 is 1 times 2, 4 is 1 times 2 times 2, and we look and see what factors do they have in common. Well, here's a factor of 1 in common, here's a factor of 2 in common, and that's all they have in common. So the greatest common factor, or GCF, for the coefficients is 1 times 2, which is 2. Now, how about the variable parts? So we have xy squared and we have x squared y to the fifth. So xy squared and x squared y to the fifth. Now again, here's that y to the fifth, so we don't want to write that out completely as y times y a bunch of times. So what we can do is use our shortcut technique that we discussed in the previous example in the last video. And the way that works is y to the fifth, y squared. The 5 is the larger power, so what we're going to do when we get to this part is just write y to the fifth as y squared times y cubed. Okay? So because we're doing that, we should also just write this one as 1 times x times y squared. Now, we don't have to do this for that one, but it does make it a little simpler once we look for the common factors. And x squared times y to the fifth is 1 times x times, now y to the fifth, again, is going to be y squared times y cubed. Okay? So why didn't we do that with the x? Well, we just have x and x squared, so the most we have to write is x times x, which is not bad at all. And anyway, we really can't do the shortcut because the only other thing we have up here is just x. So x and x squared, not bad at all. No points, not really even able to do it there. But here, y squared and y to the fifth. Writing out y to the fifth as y times y times y times y times y could be a little tedious. So we'll use that shortcut technique where we have y to the squared times y cubed. And to keep it simple, we just leave this y to the squared as y squared. How's that keeping it simple? Well, when we look for common factors now, here we have a factor of 1 in common. Here we have a factor of x in common. And then here's our y squared that they have in common. Okay? And x times y squared is completely out of factors, so that's all they can have in common. So then the greatest common factor for the variable part is 1 times that x they have in common times the y squared they have in common, which is xy squared. So the greatest common factor for the entire algebraic expression, the overall GCF, is going to be this 2 times that xy squared, which is just 2xy squared.